All right, you guys, we are going to learn a little bit more about different measures of center today and talk about some different kinds and when to use which one and all of that good stuff. So here we go. Okay, so first of all, you guys, I want you to use your calculator and I want you to input your data into list 1 and I want you to use what you know. Remember, you're going to go to Stat and Edit and put your data in. I want you to know that you have to put 105,000 in one time. You have to put 60,000 in 3 times. You have to put 30,000 in once. Da 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 da. Okay, so know that you should have 20 pieces of data entered into list 1. Okay. Then I want you to find the mean, the median, the mode, and the range. Remember, you're going to do that doing Stat over to calculate number 1, which is one variable statistics, and then find it that way. Remember that the mean is the x with the line above it. Okay, the mean is the x with a line above it. The median, if you scroll down, will be down under the 5-number summary, and then the range obviously is the min to the max. Okay, the min to the max, so you're going to subtract those. Okay, so I want you to hit pause and I want you to do that, and then you can check your answers here. Okay, just make sure you know how to use your calculator and do that. All right, if you do that on your calculator, which I taught you to do the last time, then your mean should end up being $33,250. Your median should be 24,000. Your mode, and mode we haven't really talked about, you guys, but mode is the most common, the most popular piece of data on the list. In this case, the most popular piece of data on the list is 21,000. And the range is the difference between the min and the max, and that in this case would be 84,000. Okay, so hopefully you did those okay. All right, suppose that at this company they were going through contract negotiations and they were looking at all of this data, and some of them were reporting the mean, some of them were reporting the median. Different measures of center would be here, okay? Suppose this company was in contract negotiations and the owner of the company was wanting to get people on his side. Which statistic would he probably use to describe the company? So the owner was wanting people to get on his side. And if I were the owner, in this case, I would probably use the mean. Okay? And I would use the mean because I would want people to believe that my employees make plenty of money and they certainly don't need any more. Okay, so if I was the owner of the company again, I would use the mean because I would want my employees to believe that they made plenty of money and I don't know why they're asking for any more. Okay. The union leader might want to use the mode. Okay, and the union leader who's trying to fight for his people might want the company president and the public to know that, you know what, our people only make about $21,000 a year and we deserve much more money than that, and we are asking for more money and we need it because we hardly make diddly squat. Okay, so if you're the union leader, that's probably what you would do. You would probably want people to know that you're not making very much money, you're underpaid, and you deserve or need more money. A statistician in this case probably would use, and you would have to know, but I would probably use the median in this case. If you were to take this data and make either a box plot of it or a histogram of it, you would see that it is skewed. And when data is skewed, the way to describe it best is to use the median. Okay, you're going to use the median as the measure of center when your data is skewed. So this is certainly definitely skewed data, and I would use the median. Okay, and again, if you want to see if it's skewed, you could make a histogram or a box plot on your calculator and it would show you that. Okay. All right. Outliers, you guys. If you have either exceptionally high or exceptionally low data and you average them, you add all the numbers up and you divide by however many there are, that exceptionally high or exceptionally low number is going to definitely change your average or your mean. Okay? But if you stack the numbers in order from smallest to largest, and then you find the middle number, if you have an exceptionally high or an exceptionally low number, it's not going to change very much where your middle number is, okay? Because you would cross one off from either end until you get to the middle, and it's not going to affect where your middle number is. So the median is not so very affected by outliers, but the mean definitely is, okay? When a graph is skewed, the mean gets pulled that direction, and the median doesn't change a whole lot. Okay, and we'll look at some pictures of this and talk about it in a minute. Okay, salary and money graphs are almost always skewed, and I want you to think about this. What direction? Are they skewed left or skewed right? And here's what I want you to think about. If you have a little graph, okay, and down here would be the salaries, and up here would be the frequency, or how many people have that given salary. You know that down here you have the people that make hardly anything, okay? And as you move to the right, if you were to make a histogram, over here would be the people that make a lot of money. So over here we know is little money, and over here we know is lots of money. Okay, and I want you to think about how those bars would be. And I think you can see that in almost any company or business or organization or whatever, there are an awful lot of people over here that don't make very much money. And then you get over to, like, you know, the CEOs and the presidents and the whatever. So I hope you can see that salary and money graphs are almost always skewed to the right. Almost always. Okay. Then, this is super duper duper important. When you have data that is symmetric, you want to use, because it's symmetric, you can use the mean and the standard deviation to describe it. So the mean is what you're going to use to describe the center, and the standard deviation is what you would use to describe the spread. You can do that when the data is symmetric, because if it's symmetric, you don't have outliers that are pulling that mean one direction or the other. So mean and standard deviation are the way to go there. Okay, then if you had skewed data, you would use the median, which is part of the 5-number summary, just so you know that. And that would be what you would use to describe the center. And then you would use the IQR, or the interquartile range, the difference between Q3 and Q1, to describe your spread. Okay. Here's a question for you. If the standard deviation on a list of numbers is 0, does that mean all the numbers on the list are the same? Why or why not? Okay. Again, standard deviation describes spread. It gives you an idea of how varied your answers are. So if you have a standard deviation of 0, that is having you assume that there is no spread, that there is no variation in the data pieces, no variation whatsoever. And if there is no variation, then your standard deviation is going to be 0. So yes, this is a true statement. And then all numbers must be the same for there to be no spread. All numbers must be the same in order to have no spread, or to have a standard deviation of 0. Okay? All right, then this is kind of an example we're going to work through in a couple different pieces here. But the CDC, which stands for the Center for Disease Control, completed a health and nutrition survey, and they measured several different variables, but included it in this survey. So part of the people that took part in this survey were 80 men that were between the ages of 19 and 24 years old. Okay? Their height on average was 5 feet 8 inches, between 5 feet 8 inches and 5 feet 10 inches. So they're all really similar people. They're all men. They're all about the same age. They're all about the same height. Okay. Then what they did is they looked at their weight. So they kind of eliminated some of those other variables and they looked at their weight. Okay. And you can see the histogram down there of what their weight is. So here's the original histogram and the original box plot. You can see that it's a little bit skewed right, that there are certainly lots of people that are on the lighter side, but there's some exceptionally heavy people on that survey. Okay, so just kind of know that, look at that. Their average weight was 82.36 kilograms. Okay, so just look at that and then we're going to move on. Okay, so that's what happened first. So then the National Health Institute got involved, and their recommendation is that men this age and this height should not weigh more than about 74 kilograms. Okay, so they looked at all the weight of the men, and they're like, ooh, there's a lot of overweight men in this survey. They shouldn't weigh more than 74 kilograms. Let's compare their distribution if we figure out how far overweight they are. So what they did is they subtracted 74 kilograms from each of these data pieces in here. Okay, so they took these data pieces in here and they went, oh, this is how much the men do weigh. And then if I want to figure out how much overweight they are, I'm going to subtract 74 from that because I want to know how much over or under 74 they are, basically. Okay, so when they did that, then they made this histogram right here. Okay, so they took 74 kilograms, subtracted it from every data piece in the original set, and got over here to make this histogram over here. Okay, the reason you see negative 24 is there are some people on there that are 24 kilograms under the recommended weight of 74 kilograms. Okay, so that's why it seems weird, but there is negative weight there because it's comparing it to the recommended weight of 74 grams. Okay, so what I want you to know is I want you to look at what the mean and the spread are on each of these pieces of data, okay? And it actually told you that. It told you it in the reading if you read up above. But the mean right here is 82.36 kilograms. It told us that. And the spread, we're going to look. The spread is about, and we don't have exact data pieces, but if you go from here to here, you will see that the spread is about 120 kilograms. Okay? The spread is about 120 kilograms. Then with this data piece on the right here, they again calculated the mean, and they told you that up above that the mean now was 8.36 kilograms, okay? Because they subtracted 74 kilograms from every piece of data, every person's weight in the original set, and they got now an average of 8.36 kilograms. Then, if you look at the spread of this data set, or this histogram over here, again, it's going to be about 120 kilograms. Okay? So, here's what you need to know. What I did, again, to every single piece of data was I subtracted 74 kilograms. I did the same thing to every single thing, every single piece of data. Okay? And when you do that, so here we go. When you add or subtract the same number, a constant, the same number, and again, this is key, adding or subtracting is key. When you add or subtract a constant from each piece of data, it adds or subtracts the same constant to any measure of position. So it adds that same number to the mean, to the median, to the percentiles, to the min, to the max. So if your mean was 10 and you added 20 kilograms, your new mean would be 30 kilograms. Okay? But it leaves the measures of spread, which are range, IQR, standard deviation, the same. So anytime you add or subtract a number, it is going to add or subtract that same number to the mean, but it is not going to change the standard deviation or the IQR or the range. Okay? So if you look back here, let's look at this. If you compare the two means, you will notice that the difference between the means is 74 kilograms less on this set of data than it was on the first one. That makes sense because I subtracted the same constant from every piece of data. So when I subtracted 74 from every piece of data, it's going to make my mean 74 kilograms less. Okay? If you look at the spread, they're about the same in each case. It doesn't change the difference between the highest and the lowest weights. The highest and the lowest weights are still going to be the same proportion apart. So the spread or the standard deviation, if we wanted to look at that, would be about the same in both cases. Okay, so that's when you add and subtract the same number to both, everything in the data set. Okay, now we're going to look at another one where we're going to multiply the same number. Okay, here what they're doing is they're going, oh, we reported this data in metric units, we reported it in kilograms, maybe we should report it in pounds instead, because some people, especially people in the United States, understand that a lot better. So then what they did is they took everybody's initial weight, which was in kilograms, and they multiplied it by 2.2 because that's how you convert kilograms to pounds. Okay? Here was their weight in kilograms, the initial set. Here was their weight in pounds, which is the the second set, okay? So to get from here to here, what I did is I took every single number on the data set and I multiplied it by 2.2. Okay, just so you know. Notice what I did is I graphed them on the same scale down here so that you can see how this histogram compares when I'm comparing apples to apples on the same exact scale. Okay, so the mean of this set down here was 82.36 kilograms. The mean of this set was 119.46 kilograms. Okay, the min over here was 54.3, and you can see what the min is over here, okay? The range is a way to describe the spread, and you can see that they're a little bit different, okay? So, when you compare measures of center and spread, notice that this time, not only does the mean change, but the standard deviation changes along with it. It is much less spread out from here to here than it is from here to here, okay? Much less spread out. In fact, it's 2.2 times less spread out, okay? So here we go. When we multiply or divide all the data values by a constant, it either multiplies or divides that same constant to all the measures of position. So when I multiply every number in the data set by 2.2, I'm going to need to multiply the original mean or the original median or the original percentiles, all of that by 2.2, okay? When I multiply the original data set by 2.2, I also am going to have a 2.2 times bigger spread. So I would have a 2.2 times bigger standard deviation or IQR or range. Okay? So that's what's going to happen. So when you add and subtract that same number to the mean, but the standard deviation stays the same. When you multiply a set of data by a constant number, you multiply the mean by that number, and you multiply the standard deviation by that number. Okay? All right, then the last one is I'm going to give you some measures of center and some measures of spread, and you are going to have to match the correct histogram to the correct measures of center and spread. Okay? So what I always have people to do first is I always have them start with spread. Okay? And what I want you to do is I want you to compare the three sets. This one goes from 0 up to about 30, so that's got a spread of about 30. This one goes from 3.5 up to about 9 or so, certainly a smaller spread. This one goes from -15 all the way up to about 27, so again, a really large spread. This one stands out to me compared to the other two of definitely having a small spread. Okay, much smaller spread compared to the other two. Definitely a much smaller spread compared to the other two. Spread is measured by standard deviation. So I know that because this one has a small spread that this is variable too. Okay. Then I'm going to look at the shape of the graphs, because the shape is going to give me an idea of what happens here. This one is clearly, strongly skewed right. Okay. And because it's skewed right over here, the mean gets pulled to the right, and so I know the mean gets pulled to the right. So if this is the median, this has to be the mean. Okay, the mean is going to get pulled to the right because it is skewed right, so I know that the mean has to be significantly bigger than the median. Okay, this one is a little bit more symmetric than the first one. Okay, so I know that it is more symmetric than the first one. It is still skewed right probably, but is more symmetric than variable 1. So what I know is that the mean is going to have to be a little bit closer to the median than variable 1. Okay, so when I go back up and I look at my set of data now, and I compare the mean to the median, in this one right here, the mean is definitely significantly bigger than the median, so this is going to be variable 1, which means this is going to be variable 3. The mean is still bigger than the median, but not as big of a jump, okay, because it's a little bit more symmetric. So hopefully that helps. All right, then you guys, this is going to come up on your accelerated math homework for tonight, and it's going to be some questions about different misleading graphs. And the key thing that you want to look for, as I'll kind of go through some of these, but it says both graphs represent the number of new clients signed up each month at Excelsior Realty. Which statement is true? Okay, so first of all, the graphs use different data. When it asks you that, here's what I want you to look at. It says that in January there's 50 customers here, and in January there is not 50 customers here. So they actually use different data here because January has different numbers of customers. So different data, that's not true. Okay. The scales on the two graphs are exactly the same. Well, the scales on the two graphs aren't exactly the same because this starts at 0. This one over here doesn't start at 0. They aren't exactly the same. Okay, so that is not true. The second graph does not distort the data. Here's what I have to tell you, and this is going to come up a lot. You need to look for these little skips right here, okay? And sometimes it won't even have this little symbol in here. Sometimes it'll just have a graph, and it'll just say 50, 100, but it's not going to have the little skip in there, okay? So look for that. This right here, when it has a skip or it jumps right from 0 to an uneven scale somewhere along there, that is very distorting and very misleading to the graph, okay? So this does distort the graph. It is not a true statement. So in this example, actually the answer would be this, okay? This is very distorting. So that should do it for tonight. Hopefully that will help you and this homework will go good.